Video for a class. This is Unit 6, Lesson 8, Vocabulary Review. An equation stating that two ratios are equal is a, Samantha? Proportion, very good. Okay, the first proportion we have here, okay, remember these are two ratios, they're equal to each other, that's a proportion. We could solve that. We have a couple strategies. Who can walk us through their answer? I don't want to know your answer, I want you to tell me how you got to your answer. Makeda, go ahead.
So first, because the numerator for x over 4 is a variable, so I look to the bottom, and I saw how much 4 goes into 8, which is twice, so then that means we're going to have to multiply. So I divided 12, divided by 2 is 6, so 6 over 4 equals 12 over 8.
Okay, I like your method. I want to make sure that I write that up here. Okay, so you found a factor that takes us from one denominator to the other. So that goes from here to here, and that was a factor of 2. So you multiplied by 2, right?
Yeah.
And so what you did to find out x is what?
I divided.
Okay, so we went back this direction. Because we're going the opposite direction, we divided by 2. And then we found that x equals what?
6.
Okay. Now that was the mental method. But what you could have done is use cross product. And then what you have is 8m equals 48. Divide both sides by 8. And then you still get the same thing. So I try to color code this. 4 times 12, that's the first product. And then x times 8, that's the second product. I put m here, that's just a typo, that should be an x. So 8x, I changed the variable, I apologize. 4 times 12 is 48. Then to isolate my variable, I divide both sides by 8, and then our variable equals 6. Okay? Question? You want to go through the next one? Okay, can you walk us through the next one? Walk me through the next one.
So I did the top, and which is 4 times 4 equals 16.
Okay, so you notice that going this direction, if I multiply by 4, I get 16. Then what?
And then you divide by 4.
Okay, so going back to b, we see that we have to divide by 4. And what did you find b to be? B equals what? 12. Okay, that's the mental method. If you use cross product method, this is going to get you there most of the time. Okay? Mental method only works for the really easy ones. So cross product, 4 times 48, b times 16. 4 times 48, 16 times b, that's going to end up being 192 equals 16b. And then how do we solve that? How do we isolate our variable b? What's the next step? Richard? Divide by what? Divide both sides by 16. And then if I divide both sides by 16, I get back the same result. 12 equals, again, I have another typo. That's G. I copy and paste, so I apologize. You guys know that that's B. Okay, I'll fix it. Better? Good. And then over here, I should make this an X. All right, better? Good. All fixed. All right, Caden, walk me through this one.
So first I did 84 times 6.
You did 84 times 6?
Yeah. Because I cross multiply.
Oh, you did cross product. Okay. So you did cross 84 times 6, and then what else?
And then I divided.
Well, hold on. That's one. It's cross products. Remember, there's 2 of them. What's the other cross product?
Oh, 12G.
Nice. So 84 times 6, and then 12 times G, and then what did you get for 84 times 6?
504.
504. Okay, so 504 equals 12G. How do we get G by itself?
You divide it.
Divide by what? I want to get G by itself. What's with G? It's 12 times G, right? So I got to get rid of that. What's with G?
12.
So I want to divide both sides by 12. Okay, remember that makes it go away. And then what'd you get for 504 divided by 12? What was that? Did you have it?
I did another one, but I got G equals 7.
Okay. Not 7. 42. Okay.
I did another one. I missed
Okay. But if you got to this point, this is just solving an equation like we've done in the past. Okay, isolated variable. So it sounds like you might have a calculation error. Okay, you can go back and verify the answer. And who wants to walk me through this last problem? Sergio. Last problem, walk me through it, please.
How I got it?
Yep. I see some motions. What do your motions mean? What? We gotta know how we get to the answer. How is anybody else gonna get the answer if they just know the answer? We need everybody to know how to get to the answer.
Of course, cross products.
Cross products. Okay, can you tell me the first cross product?
6 and M.
Okay, 6 times m, and then what's the other cross product?
19 times 3.
Thank you. So we got 6 times m. Oh, I have another typo. I thought I fixed that. So that should be 6 times m. Okay, and then that should be a 19. 3 times 19. Man, it's Friday. I'm not here. Is that okay? All right. All right. So 6 times m, 3 times 19. And what did you get when you multiplied 3 times 19?
57.
57. Okay, and then we got isolate my variable, dividing both sides by 6. And what did you get when you divide 57 by 6?
9.5.
Very good. So this is an example where it's not as easy to do that mentally. You have to work out the math. You might be able to do it mentally, but the cookbook method, you have a proportion, cross multiply, isolate your variable. Okay, any questions about that? Are we good? Okay. All right, since I'm trying to put together the video for the class channel, YouTube channel, I'm going to go ahead and read this. What you'll learn: to solve proportions to find missing lengths in similar figures. New vocabulary: polygon, similar polygons, indirect measurement. Okay, why learn this? The height of objects such as totem poles may be difficult to measure directly. You can measure indirectly using figures that have the same shape. When two figures have the same shape but not necessarily the same size, they are similar. Okay? In the similar triangles below, corresponding angles have the same measure. Since 40/60ths, you guys take a look at these triangles. I'm trying to get you guys a look, and I color-coded them. 4/60ths, and notice this side and this side, I'm matching them up. They're called corresponding sides. And look at this, 50/75, these sides correspond. And then take a look at this, 34/51, those sides correspond. You guys see that? So this side and this side match up. This side and this side match up. This side and this side match up. They're called corresponding parts. And we're going to see how we're going to use equations, our strategies to solve equations, to solve some really simple geometry problems. Okay? So I'm trying to teach you guys a few things today, not just solving proportions with similar figures, but I'm trying to get you guys familiar with some other things. Okay, so do you see this little wavy line right here? Okay, that means similar to, and for me, the way I remember it, if it kind of looks like an S laid on its side, right? Okay, so that symbol means similar to, and here's what similar to means. If you have two shapes and they're similar, that means they're the same shape, but one could be a smaller version of the other shape. Does that make sense? So I'm just trying to use not any special language. I'm just trying to explain to you, if you have two shapes that are similar, it's the same shape, but just a different size of the same shape. Does that make sense? Now, here's the other thing about similar shapes. If they're similar, the angles have to be the same. okay? So when we measure the angle formed by two sides, the degree measure is how do these sides pinch down on each other? Do you guys understand? They meet at a point called a vertex. How do they meet? Well, the angle tells us how they meet. So if you look, angle B is 53 degrees, and that corresponds to angle G, which is also 53 degrees. So what corresponds with angle A? Can somebody tell me what corresponds to angle A in this other shape, and what's the measurement of angle A? Go ahead, Sergio.
F and the angle is 83.
Right, so A is 83, and it corresponds with angle F, which is also 83. Okay? Can somebody tell me what angle corresponds with angle H? Kimberly. Angle C. And notice angle C and angle H have the same measure, which is 44 degrees. Got that? Okay. So the first part of a shape that's called a polygon are the angles that are on the inside the shape. So the smallest number of sides you can have for a polygon is 3. Okay, what's a 4-sided polygon? Can somebody tell me what a 4-sided polygon is? Richard? A quadrilateral. A four-sided polygon is a quadrilateral. What's a 5-sided polygon? Go ahead. No, that's a 6-sided polygon. A hexagon is a 6-sided polygon, but it is a polygon. That was what I was going to ask you next, so you kind of beat me to that one. Who can tell me what a 5-sided polygon is? Isaiah. A pentagon. Okay? 5 sides, pentagon. Okay? So a pentagon is a 5-sided polygon. So polygons all have angles that measure between two sides. They're called interior angles. So a triangle is going to have 3. How many angles do you think a quadrilateral is going to have? 4. And then a pentagon, how many interior angles do you think that'll have? 5. And then how many interior angles in a hexagon? Okay. So here's something else I want you guys to think about. Now, in order to have a polygon, a polygon is made up of line segments. Remember a line segment? It has a beginning and an end. Do you guys remember that? And so line segment AB, line segment AC, and line segment BC, those are the line segments that make this triangle. Do you guys understand? Okay. And then line segment GH, GF, and then FH. Those are the line segments that make this triangle. All right, so the side that corresponds with AB is what? Class? What's the side that corresponds with the side AB? FG, very good. What's the side that corresponds with CB? GH, very good. What's the side that corresponds with CA? FH, very good. So here's the rule about similar polygons. Now, before we move on to the rule about similar polygons, a polygon is a closed figure formed by 3 or more line segments that do not cross. So the polygon with the least number of sides is the triangle, and then it just goes up from there. Why can't you have a 2-sided polygon?
Because it's not the same.
Okay, I see some of you making like you're trying to figure out with your fingers as line segments, right? Let's take a look at this. Do you guys see this part of the definition that says it's a closed figure? Do you guys see that? What do they mean by closed figure? So I have a lot of people calling out. Can I get somebody to volunteer and explain to the class? Maya? It won't be able to connect. Well, you could connect if you connect the endpoints, but then it just looks like a line, right? Okay. So, and that's only if the 2 line segments were the same length. You're right. If I had one that was a different length, then I could connect one end, right? But I couldn't connect the other end, right? So a closed figure formed by 3 or more line segments that do not cross. They can meet at the tips, and the tips where they meet is called the vertex. And here's the key concept for the day. We're going to see how we're going to use this key concept. Similar polygons. 2 polygons are similar if corresponding angles have the same measure. So you notice these 2 are similar and they have the same measure for the corresponding angles. And the length of the corresponding sides form equivalent ratios. So if you guys look, do you see how I matched up my sides to make these ratios? Yeah. Okay. They form equivalent ratios. Now notice, what do you notice about all the numerators here? Where did they come from? Which triangle did they come from? The one on the left, which is the smaller one. Look at the denominator. Which triangle do the values in the denominators come from? The one on the right. I want you to pay extra close attention to that because today's problem we're going to learn how to solve, that's where students always mess up on setting up the problem. So watch. Here's the problem we're going to solve. So do you guys see these two triangles? Yeah. I'm telling you right now because of this symbol. Do you see that symbol? You see that symbol? What does that sideways S symbol mean? Similar, right? And so a lot of times in geometry they use symbols instead of a word. And so instead of writing the word triangle out, do you see this triangle here? That just says that's the word triangle. Triangle ACT. And notice ACT, do you guys see the order? ACT, it just goes in one clockwise order. And then it's not coincidence that I start on A, I also start in the same spot, ODG. Do you guys see that? And it goes in the same order. It goes in the same direction. That's not coincidence. We're going to learn later why they do that. Okay, and we know that that symbol means similar to. We need to find the value of x. So let me walk you through one way to do that. First of all, I need to find x, right? What can I match with x? What matches with my x? Savannah. 50 centimeters. And we don't like to use the word match. We use, in geometry, we use a word, and it's corresponding part. So these sides correspond to each other, okay? So we don't like to use the match. We use correspond, okay? So x and 50, those correspond to each other. Now, I'm going to go ahead and set up the problem for you. And remember that x over 50. Do you guys see that? Okay. I could have put 50 over x, but whatever way I pick, I have to stick with that. Does that make sense? So now, I have this, and I made a ratio out of it. Now what I want to do, and I'm going to go ahead and show you the rest of it because there's more than one way to solve this problem. I put 32 over 40. Do you guys see, why didn't I put 40 over 32? So first of all, do you see 32 and 40? Do you see how they're connected? This side corresponds to this side. Do you guys see that? Yeah. Why didn't I put 40 over 32?
Because it would be an improper fraction.
Well, not an improper fraction, because we can have an improper fraction, but it really has to do with this first one. Go ahead, Savannah. Because you guys see where I already put the x in the top and this in the bottom? So if I put a measurement from this shape in the top, then any measurement I put has to be in the top that comes from this triangle. Do you guys understand? That's where people mess up all the time, okay? So when I'm setting a proportion, whatever I pull and put in the top over here, if I pull another number from this shape, I got to put in the top over here too. They have to both be in the top. Now, so you guys understand how we set this up? Now guess what? It's just like my warm-up. It's just like the warm-up. You guys know how to solve this, right? Yeah. What are we going to use to solve this? Cross products. Remember, that's plural. It's two cross products, not one. It's not cross product. So 32 times 50 and then 40 times x. And I'm just going to tell you to speed things up. 32 times 50. Boom. There we go.
I was doing it.
It's okay. I wanted to get through and let you guys try on your own another way. Okay, so how do I solve for x? What do I do? Divide by what? 40, both sides. And then 1,600 divided by 40. I'm going to tell you right now, it's just 40. Okay. Now, here's what I want you to do. Yep.
So does it matter which side that they use?
That was what I'm going to have them do next. Now, I don't want you to use 32 and 40. I want you to use the other side that I didn't use. You have to use this because we have to find x, so we have to use that ratio. So can you find another proportion that doesn't use these two sides that you can solve to get x? Shh, I hear you calling out. I want you to try. I want everybody to try on their own and investigate for themselves to see if you have to use one particular side to set up a ratio. So Jabari, can you tell me what other ratio you use so you can set up your 24? And 24 and 30, which one did you put in the numerator? Which one did you put in the denominator?
Put 24 in the numerator?
That's correct. Right, that's correct. Why did you put 24 in the numerator?
Yes. Because the number is smaller?
No, here's why. Look, since my x's are in the numerator and that came from this shape, then the 24 that you're using has to also be in the numerator. Okay?
Yeah.
Okay. How many of you guys found that other ratio? Did everybody else find that same ratio? Okay, good. Jabari, can you continue to walk us through solving this problem?
Well, I use cross product. So
Very good.
4 times 50.
Okay, and what else?
And 30 times x.
Nice. Okay,
And gave me 1200.
nice. 1200 equals 30x. Then what are we going to do?
Never mind.
Isolate x.
Okay, we're going to isolate x. How are we going to do that?
Divide by 30.
Nice. And then when we divide by 30, what do we get back? Well, you know 12 divided by 3 is what?
4.
It's 4, right? So 1200 divided by 300 is going to be what you just said, 40. All right, so 2 different ways to solve this one. There's normally, on these problems, there's normally more than one way to solve it. Okay, now a triangle has only 3 sides, so there's only so many ways to rearrange your proportions, make your proportions. You're going to find that if you have more sides, that you have more ways to solve it. So here we go. Now they're trying to trick you. Do you see how they're trying to trick you in this problem?
Yes.
How are they trying to trick you?
By adding more sides.
Leonardo. Yeah, do you hear what he said? They flipped one of them over in the different direction, but guess what? They're still similar, but they flipped it. And by them flipping it, they're trying to confuse you on what the corresponding sides are. Do you understand?
Yeah.
But we're not going to fall for that because we know that it's flipped, right? So there is one ratio that we have to pick because we're trying to figure out what? We're trying to figure out what the x is. So I have to pick the ratio that's got x in it. Okay? So which shape has x in it, first of all? The one on the right. Okay? Now, the one on the right has the x. You could put that x in the numerator or the denominator. I went ahead and I put in the denominator. Just to show you that you don't have to put the larger size in the denominator, in the numerator. You could put in the denominator. You don't have to always. I could have solved the same thing by putting x over 10, but then my other fraction would have been 12 over 6. Do you guys understand? So I want you guys to see something. The same answer comes back if I do this. I just have to be consistent. If I choose x to be in the top, then anything I pull from this shape has to also be in the top. Do you guys understand what I mean about being consistent? Okay. This is going to give me the same answer. I want to show you why. Cross product. What's the cross product going to be? 6x is going to be equal to 120. Right? You see that? And I'm just going to walk you through this. Divide both sides by 6. We get x equals 20. Just like here. Divide both sides by 6. I get x equals 20. Okay. Now what I want you to do, I want you guys to solve this another way. Because we have 4 different sides, unlike the triangle that we only had 3 sides on, 3 different sides. We have 4 different sides here. Right? So you have more options now. You have more possible ways to set up the proportion. I would like for you to find another proportion to set up and solve it. You should get the same answer back. You should get x equals 20. No matter how you set it up, if you set it up correctly, you should still get back 20. so take your time. Set it up a different way.
With the same numbers?
Well, the only thing that you don't have a choice on is what? The x and the 10, right? You have to pick that ratio because you have to put x in your proportion because you're trying to find x. If you don't put it in your proportion, you're just going to have two equivalent fractions, and that's not going to get you anywhere. Yeah, just take my pass. Okay, what I'd like to hear is somebody's alternate solution. Kimberly, go ahead. You did 3 over 6? Okay, so if you did 3 over 6, what did you match that up with? So your proportion you have is 3 over 6 equals what? Now look, if you put 3 over 6, you chose the 3 from the small shape, right? Okay. And then you got to put the 10 from the small shape over the x. Okay? Yep. That is? Oh, I'm sorry. That's correct. Are we good? Did somebody have another way? Did somebody have a different proportion that they set up? This is correct if you set that up. That's correct. Does somebody have another one? Go ahead, Makeda.
10 over 6 and then 12 over x.
10 over 6. 10. Oh, well, you can't. I have a 6 over. If I do 10, it's got to go with that x. Okay. Are you talking about this 10?
Yeah.
This would go with the 5, right? This 10 would go with the 5. So is that what you did? Yeah. Okay. So if you use the 10, you made a ratio of what was your ratio? So here's one proportion that works right here. That was Kimberly's. And if we solve that, it'll give us the same solution. But what I'd like to hear is, it sounds like Savannah used 10 and 5, the side segment NO and FG. Okay, so tell me what your setup was going to look like.
I did 5 over 10.
Okay, so you did 5 over 10, and then that equals to what?
X over the
Now look, 5 over 10. 5 is from the smaller shape, right? And you put that in the numerator? 5 over 10. Okay, so go ahead.
And then I put the X over
You're mixing it because you put the measurements from the small shape in the numerator for your first one, right? So so if you have 10 and x, these two sides that correspond, EF and MN, I got to make sure that this 10 is in the numerator because all of these you have to put in the numerator now. Because once you put this 5 in the numerator, then that means my next measure, you said 10, has to also be in the numerator. Do you understand? Okay. Anybody else does somebody have something different? So that's another proportion we could use. One I haven't heard yet, I'm kind of surprised. It's similar to, somebody have another one? No? Let me go over this last one. The one I did was like, is similar to Kimberly's. So here we go. Cross product. So 3 times x, 6 times 10, we see that 3x equals 60. We solve by dividing both sides by 3, and we get the same answer back, x equals 20. Okay, any questions? I think what I'm really trying to focus on is how you setting up the proportion. Yep. Yeah, go ahead. Okay. All right, so I have another problem for you. So these are alternate proportions over here. And if you solve these, you'd get the same answer back. Now let's move along. All right. You can use indirect measurement to measure distances that are difficult to measure directly. You do this by using proportions in similar figures. Okay, so take a look at this example. Application, indirect measurement. A 6-foot-tall person standing near a flagpole. So this person's how tall?
6 foot.
Okay. Casts a shadow that's 4 5/10 foot long. So do you see why this part of the triangle is 4 5/10 foot? That's his shadow. They're measuring his shadow, and they have his height. And if you notice, he's standing straight up, so that's a right triangle. Do you guys see that? Okay. It's very visual. Geometry, there's pictures that go with your math, so you need to look and follow along. Now, the flagpole casts a shadow 15 feet long. Do you guys see that? They want to know how tall or what's the height of the flagpole. Well, it'd be kind of dangerous to go climb the flagpole and measure from the top of the flagpole. You don't have to do that. There's a way to do it with math and similar figures, okay? So let me walk you through this example because it's not any different than what we did. So first of all, these two triangles are similar. Do you see the triangles that draw out the shadow and the height of the flagpole? And that's the hypotenuse. And here's the triangle created by the height of the person and his shadow. Do you guys see that? Okay, now we have to set up a proportion. So what am I looking for? I'm trying to find x, right? And so x is right here. And what corresponds with that side of the triangle? 6 foot, the height of the person, right? So here we go. You guys see what I just did? So 6 is the height of the person over the height of the flagpole. Do you guys see that? Okay, I got to set that equal to another ratio, right? Okay, and I have to be careful. I want to see if you guys heard what I was telling you with the earlier problems. I only have 2 more measurements left, right? It's the shadow of the flagpole and the shadow of the man. So, with my ratio, what's going to be in the numerator? Somebody I haven't heard from would be nice. What's going to be in the numerator? Remember what I said about the other problems? I was trying to get you guys not to make that mistake. Yes, Ms. Ford.
4.5.
Yes, and why did you choose that to be in the numerator?
Because in the other fraction ratio,
Yes.
they put the man's height or
Right. Very good. So because this ratio, we already put 6, the height of the man, in the numerator, that means in this ratio, the shadow of the man needs to be in the numerator. Okay? And that corresponds with the shadow of the flagpole, which is in the denominator, and the height of the flagpole, which is in the denominator in the first ratio. Do you guys see how we set that up? Okay, and I'm trying to color code it so you guys see where everything's coming from. Okay? Now, you guys know how to solve that. Cross product, here we go. So I got x times 4.5, and then 6 times 15. And I'm just going to tell you guys right now, that's 90 equals 4.5x. Now, how am I going to get x by itself?
X out the 9.5.
No. Can somebody help Caden out? Jabari. Divide by what?
Oh, by 90.
Divide by 4.5. So Caden, I got to look at the side that's got x. And I got to get rid of what's with x. Well, 4.5 times x, that's what I got to get rid of. So I got to divide both sides by 4.5. Does that make sense? Do you understand why it's that, though? Are we good?
Yeah.
Any questions about that step?
So
Now,
you always divide by the right one instead of
No, you divide by what's with the variable. Because the variable can be on the right side or the left side. Okay, you want to get the variable by itself, so I got to get rid of that 4.5, so I'm going to divide by it. So when we divide it by, I'm just going to tell you guys right now, it's just going to be 20. The height of the flagpole is 20. Okay, any questions about that example? Because now I'm going to have you work one out on your own. A 6-foot-tall person has a shadow 5 feet long. Here's my person. There's my shadow. The book didn't give a picture. I put the picture together for you guys. A tree nearby has a shadow 30 feet long. Okay, what is the height of the tree? Do you see what I have for the height of the tree? What did I give for the height of the tree? X. Okay. Do you guys think you can set that up and solve it? Let's try. Let's try to do this. And you don't have to make a picture perfect triangle. If you're going to draw it, just sketch it out, just so you can see where the information comes from. Good. I'm looking around, seeing some proportions. In a moment, we're going to check to make sure we got the setup right. We make sure that our ratios, that we took the same measure from the same shape in the numerator or the denominator. We are almost done. Okay, can somebody share with the class the proportion that they have? What is their proportion? It's the two ratios that are equal to each other. What's your proportion? I don't think I've heard from Richard today. Go ahead, Richard. Okay. Right. So here's Richard's. He got x over 6, and then he got 30 over 5. Okay. That's one way to solve it. Did somebody get another proportion? What'd you get?
I got 6 over 5, and then x over 30.
No, hold on. You took 6 and 5. You made a ratio out of the same shape. Can't do that. We got to use parts. One from one shape, one from the other shape. Okay? So can we fix that? Samantha?
I got 6 over x and 5 over 30.
Nice. So that's the other way. Okay. So Bakeda, take a look. These came from the same shape, and they're both in the numerator. Right? These came from the same shape, they're both in the denominator. But each ratio, one measure comes from one shape, one comes from the other shape. Do you understand? Does that make sense?
I got the 36 over 30.
6 over 30.
divided cross product.
Let's see if we got the same answer. Isaiah, do you have a question? Okay. Samantha, can you walk me through the rest of this problem?
Okay, so I multiplied 6 and 30,
Okay,
and I got 180.
very good.
And then I put 5 with x. And
Okay.
then I had to isolate the x, so I divided them both by 5.
Yep.
And I got 3x.
Okay, so this goes away, and this is 30. Is it 30x? 36x?
Oh, I got 3x.
You got 3 for x?
Mm-hmm.
Oh, it's got to be more than 3x. 5 goes into 18 how many times? 3, right?
Yeah.
So then you have 3 left over, and then 3, and then the 0 is 30. 5 goes into 36 times, so 36. That's right. Okay. Okay, this would have gave you the same result also. And if you notice, they're just flipped, right? My cross product would be the same, 5 times x, right? And then 6 times 30. You understand? It would have been the same thing. Okay? All right. Moving right along. Let's take a look. Closing. We're almost done. What must be true about corresponding angles and corresponding sides for two polygons to be similar? Remember, if they're similar, they're the same shape, different size, right? So what do we know about corresponding angles? So when we match up the angles, what do we know about the angles between two similar shapes? You guys remember? Remember the key concept? If you have it in your notes, that's what I'm trying to get you guys to remember. Makeda? So if we have like these two shapes are similar.
Yeah.
So what do we know about their angles that correspond?
Angle B is corresponded to S
Right?
and T.
So angle B, this angle right here, and this angle S, those correspond. You're answering that question, but we're trying to answer this vocabulary question up here. What must be true about that? What do we know about angle B and angle S? They correspond, but what do we know about them? Caden? So let's say this is 45 degrees. What do we know about angle S? If angle B is 45 degrees, what does angle S have to be? No, don't listen to people's answers. Think about it for yourself. Think about the first example I gave, the very first triangle I showed you guys. Here, let's backtrack. What do we see about the angles? These two are similar triangles. What did we see about the angles? Go ahead. Lauren, say it louder. So if you have similar shapes, the corresponding angles are the same. They're equal. But what about the corresponding sides? Are the sides equal? Are the sides equal? No. What do we know about the sides? Look, they show you right here what's happening with the sides. What's happening with the sides?
They become into a proportion.
They are ratios that form proportions. So let's fast forward to that last slide. Two polygons are similar if corresponding angles have the same measure, they're equal, and the length of the corresponding sides form equivalent ratios that we can make a proportion out of. Okay? Now, Makeda already answered our question here. These two triangles, triangle ABC, and notice, this time they go the other direction, ABC, they go counterclockwise, and this RST. See how they went counterclockwise? Okay, that's important for later. Now, line segment RS, do you see line segment RS? Corresponds to what other line segment in the other shape? Go ahead, Akbana. AB, very good. So this side corresponds with this side on this shape. Okay? Now, moving right along, we're almost done. The class this morning had a hard time with this problem. Geometry. Are the rectangles similar? Are these similar? Remember what we set up above. Now, they're both rectangles, but that doesn't mean they're similar.
No.
You have to verify it. We just went over the definition of similar. How do I know if these two are similar or not?
Yeah.
I see some people, they're kind of saying it to themselves, but raise your hand, share with the class what you think. And then maybe you'll get to somebody else thinking something. And then maybe we'll eventually get to the right answer. Or maybe you have the right answer. Tell me what you think. If you think they're similar, I need to know why you think they're similar. If you don't think they're similar, I need to know why you don't think they're similar. Okay, Akpana's the only one with her hand up. Go ahead. Why not? What do you mean by that?
So like 4M and then 2M, so D and C and H and G don't correspond.
Okay, so you're talking about 4M and 2M. Okay, let's talk about that some more. Go ahead. They're not, but similar means you don't have to have the same number, right? But something else has to happen. Isaiah, can you help her out? Well, we need to know how to set this up. Just like we set up all the other shapes that were similar. Do you guys remember that? Remember when we solved for missing sides to those shapes? We had to set something up, right? Okay. Ms. Ford, go ahead.
They're similar because the smaller one is almost half of the bigger.
Okay. Well, they can't almost be half. They have to be half all the way around if they're similar, or whatever it is. Makeda?
Okay, I don't know if this is relevant, but it's like this. That's 4 and that's 2. So 2 plus 2 is 4. And
No. We're not talking about add. With proportions, it's always a ratio, right? So you're on the right track. Set up a ratio. What if these are similar? What corresponds to AB? EF. Okay. So let's set up a ratio. I'm going to do 2 over 4. Okay. Now, if they're similar, they have to be similar for all the parts, right? So what corresponds to BC? FG, right? Okay, so this from AB and EF, that ratio needs to be equal to BC and FG.
Please pardon the interruption. For
If they're
everyone's
similar.
Information, the nurse has left for the day. So if you have any nurse-related
Is that
situations,
true?
the student either needs to call home
Is that true?
or stay. So emergency
Is
situations.
2/4
only
equal
be
to
sent out.
3/5?
Other than that, please keep the students in the classroom.
Who says yes? Raise your
One more
hand.
announcement, Kennedy Baker.
Who
Please
says no?
report
Raise your
yes,
hand.
Kennedy Baker.
Say it again.
It's either one choice or the other. Is 2/4 equal to 3/5? Raise your hand. Is 2/4 not equal to 3/5? Raise your hand. They're not equal. Since they're not equal, guess what?
They're not proportional.
They are not similar because that's not a proportion.
Yeah, that's awesome.
Oops, right here. No, the lengths of the corresponding sides do not form equivalent ratios. They're not equivalent ratios, so it can't be similar. Now, here, this was kind of, you could have had any answer. I'm going to give you my sample answer. Think of a distance that is difficult to measure directly. How would you find it indirectly? My example was the Washington Monument. You guys know what the Washington Monument is, right? It's that big, tall thing in D.C. that the elevator always gets stuck in, and if you ever ride in the elevator, you probably have nightmares about getting stuck in that thing, because I'm sure the stairs would get you really tired. They do, as an emergency. I think I'm pretty sure they have an emergency exit that's a stairway. And that's a lot of stairs. So, Washington Monument's height can be measured using the length of its shadow and one's height and the length of one's shadow. So think about that. If I know my height, I can measure my shadow, and then I could go walk up to the monument and measure the monument's shadow, right? I would want to measure the monument's height shadow later in the day when the sun's higher up, right? Because the shadow's not going to be as long. Does that make sense? Okay. You could do that, and you could see how close your calculations are.